Hello everyone. In this video, we will learn how to measure the concentration of VOCs. To identify the VOCs concentration and content in an environment, we first perform sampling. After that, we perform measurement. Let's talk about sampling. There are two sampling methods: whole volume sampling and concentration sampling. Using whole volume sampling method, we collect air in the environment directly for analysis. We use canisters or tether beds to collect air samples. This table shows the characteristics of canisters and tether beds. Canisters are made of specially treated stainless steel. The sampling is passive, since the canister is evacuated to a vacuum condition before sampling. Therefore, no pump is needed. Canister is inert and has a longer storage time. It can also be used repeatedly. Tether beds can be made of various materials, depending on different performance and cleanliness requirements. The sampling is active since a pump is required to pump the air into the bed. It is more economical for bulk use, and only little preparation is needed before sampling. The storage space required for tether beds is also less than for the canisters. However, the storage time for tether beds is short. Moreover, data quality and measurement objectives need to be considered when deciding to reuse the bed, as the cleanliness and innerness may be affected. The second sampling method is concentration sampling, where air is drawn through a tube filled with a combination of solvents. Contaminants in the measured environment are chemically absorbed to the solvents in the tube. Since no one solvent material can collect all types of VOCs, several solvents are selected for the measurement based on the kind of VOCs to be measured. The sampling process can be either active, where a pump is needed to draw air in, or passive, where air is collected by diffusion. Less time is needed for active sampling. For passive sampling, the absorption rate is slower. Passive sampling is used for long-term sampling. After sampling, VOCs are analyzed by sensor or separation means. Flame ionization detector, FID, is one of the sensors to detect VOC. Inside the sensor, VOCs are burned in a hydrogen flame. During the process, positively charged carbon ions are produced. As these ions are collected on an electrode, current is introduced, and the intensity of current is converted to a value of ppm. Gas chromatography, GC, is one type of instrument that uses the separation principle to detect VOCs. Separation means that the mixture of compounds sampled is separated into individual components during the process. The sample is first heated to vapor and transported to a column by carrier gas. Inside the column, the physical properties, temperature, and composition of the sample are detected and transferred into electronic signals that are recorded by a data system. This is an example of result obtained by GC. Each peak represents one kind of VOCs detected. The VOC concentration can be measured by mass spectrometry. High performance liquid chromatography, HPLC, is another separation means that utilize a liquid mobile phase to separate the mixture into individual components. The sample is first dissolved in a solvent and then forced into a chromatographic column under high pressure. Then the mixture is separated into components that react with the stationary phase. The result is thus released. To conclude, in this video, we introduced several sampling and measurement methods and instruments.